Okay, so for this lesson, we're going to be finding inverses of functions. Now, the important thing to know about inverses of functions is basically you just switch the input and the output. Now, you may remember before, if we have this function f of x equals 5x minus 7, the input variable is the x and the output variable is the y, the f of x. So I can rewrite this as y is equal to 5x minus 7. They mean the same thing. For us, we want to find the inverse. To find the inverse, we need to switch the input and the output. So for us to do that, we need to switch the x value and the y value. So I switch the x and the y. So instead of getting y equals 5x minus 7, I get x equals 5y minus 7. And because I need my equation to be solved for y, I solve for y. So first thing I do is I add 7 to both sides. So I get x plus 7 is equal to 5y, and then I can divide both sides by 5. So I get x over 5 plus 7 over 5 is equal to y. Now, obviously, this is not true. It doesn't equal y because y equals 5x minus 7. So to show the difference, I'm going to put this notation here, this negative 1 exponent. This shows that this is the inverse of y. And if you write this notation, anybody who knows math will understand this. And they'll say, oh, that's not y. That's the inverse of y. Now, because the original function was f of x, we could write f negative 1 of x. It's an ugly x, but the negative 1 exponent is perfect, and it shows us that this means that this is the inverse of f of x. This is f of x, so the inverse of f of x is x plus 5 plus 7 fifths. And, I make this comment a lot. This fraction here was just 7 divided by 5. I didn't really do any major math there. A lot of students will rush to use their calculators and turn this into a decimal. It's not necessary. Don't do that. Leave it as a fraction. That's perfectly fine, perfectly acceptable. And so this is the inverse function. So to recap, to find the inverse, you switch the x and the y, solve for y, done. Don't forget your negative 1 exponent. Now here, this is going to be important. So before we've looked at compositions of functions, well, what we want to find is f of g of x and g of f of x for these two functions. So I'm going to go through these and then show you the significance of them. So first, I want to find g of f of x. Okay, so g of x, well, g of f of x. Well, g of x is x plus 7 over 5. Now, don't forget, that's g of x. So if I want g of f of x, I get rid of the x value, and I replace it with 5x minus 7. Now, in the numerator here, I have negative 7 plus 7, which reduces to 0. So I have 5x over 5. So that means that g of f of x is simply x. Okay. Now, if I want to find f of g of x, again, I start with f of x, so that's 5x minus 7, and I replace the x with g of x. So I replace this with 5x plus 7. Now, when we do this, when we go through these, order of operations is very important here. So here, I can multiply the 5s, or multiply these two factors together, and the 5s cancel out. So I get x plus 7 minus 7, and plus 7 minus 7 is 0. So f of g of x is equal to x plus 0, or just x. Now this is cool. Notice that both these compositions, f of g of x and g of f of x, are equal to x. This means that these two functions are inverses of one another. And this is an important concept that we need to use to show that functions are inverses of each other. So if I said Oh, f of x is 5x minus 7, and its inverse is x plus 7 all over 5, um, show that they are, in fact, inverses of one another. Well, you would need to use the two compositions of functions and show that when you plug in the inverse into the original function and the original function into the inverse, they both simplify to just x. And here's that, again, written out. Again, just saying that if you have two compositions of functions and they both equal x, these two functions are inverses of one another. So, first off, for these problems, we're going to go through these problems. We're going to find the inverses. And then for the next set of problems, we're going to given two functions and see whether or not they are functions or whether or not they are inverses. Yeah. So we can do this. So all these f of x, g of x, h of x, I'm just going to start off by switching them to y. I'm going to pretend that that's y. And so first thing we're going to do is I'm going to switch the x and the y values. So x is equal to 4 over y plus 3. Subtract the 3 from both sides, so x minus 3 is equal to 4 over y. Here, I can multiply both sides by y, and then divide by x minus 3, or there's a shortcut where I can switch the y and the x minus 3. And that will isolate the y, which means that this is now the inverse. So I get f inverse of x is equal to 4 over x minus 3. And that is my inverse. For number 2, same deal. I'm going to say h of x is y. And so if I switch that with the x, I get x is equal to negative 1 over y minus 1 plus 3. Same thing, I can subtract 3 from both sides. So I get x minus 3 is equal to, this negative could be in the numerator or denominator. For simplicity's sake, I'm just going to put it right in the numerator. And so here, I can multiply both sides by y minus 1 and subtract by x minus 3. But again, I can do this little maneuver, which I like to call the old switcheroo, which I can switch the denominator with the other side of the equation. So I get y minus 1 is equal to negative 1 over x minus 3. And then I add 1 to both sides. That's going to isolate the y. So this is going to be h inverse of x is equal to negative 1 over x minus 3. Notice I put this negative sign back out front again. Doesn't make a difference. And then I add the 1. So plus 1. Depending on the instructions, maybe they want us to combine it into one fraction. But here, the instructions don't specify, so I'm going to leave it as a plus 1. Right, so number 3. This would give me x is equal to negative 1 over y plus 2 plus 3. Very similar to the last one we just did. So I'm going to subtract the 3 from both sides. So x minus 3 is equal to negative 1 over y plus 2. Switch the y plus 2 and the x minus 3. So I get y plus 2 is equal to negative 1 over x minus 3. Subtract the 2, which would isolate the y. So I'm going to get negative 1 over x minus 3, and that's going to be a minus 2. I like to put boxes around my answers, which I did not do for the first one. Kind of losing real estate here. All right, and this one, this seems like it might be a little bit complicated. And if you don't really remember, exponents and rational functions from algebra, we can try to review this as we go through it, depending on how many people are confused with this. But first off, switch the variables, and that's what we're learning right now. So that's the important part. Here I have this negative sign, so I'm going to divide both sides by negative 1. So I get negative x is equal to y minus 2 to the third. Now I have this raised to the third power. So how do you want to do it? Well, I take the third root. Much like if I had y is equal to x squared, how do you solve for x? I take the square root of both sides. Except this is not a square root, this is a cube root. So I'm going to have the cube root of negative x is equal to y minus 2. But I can add 2 to both sides. So I'm going to put this on the left-hand side. The inverse of x is equal to the cube root of negative x plus 2. So again, that whole cube root, cubed business, maybe it's a little bit tricky, maybe it's a little bit confusing, but as long as you understand the switching of the variables, that's the important part, and we can focus on those other algebraic pieces later. All right, finally, number 5 looks very similar to numbers 2 and 3. So first off, I'm going to say h of x is y, and then switch the variables. This is going to give me x is equal to 3 over y plus 2 minus 2. I'll work horizontally here because I'm running out of room. So this is going to give me x plus 2 is equal to 3 over y plus 2. Switch the x plus 2 and the y plus 2, so I get y plus 2 is equal to 3 over x plus 2. And I can isolate the y. So this is going to be h inverse of x is equal to 3 over x plus 2 minus 2. And that's my inverse. Really straightforward process for finding inverses. Very simple algebra. The concept is not, it doesn't get much more complicated than this. What does get more complicated, perhaps the types of equations or the type of functions that we're looking at or working with. But for right now, the core concept is just this. So we may look at more difficult problems, but if you can understand this, then you're in really good shape. And the next part is verifying these are inverses of one another. So again, what we need to do is we need to find the compositions of the two functions. So I need to find, for number 6, I need to find h of f of x and f of h of x. So h of f of x. And again, these should both reduce to x. If either one of them doesn't, I can stop. They are in inverses. And that's it. So h of f of x, I start with my h function. So 3, cube root. Let's butcher that. Cube root of negative x. But again, we replace the x with 1 minus x cubed and plus 1. So I get the cube root. This negative distributes in, so it actually becomes x cubed minus 1 plus 1. Minus 1 plus 1 is 0, so I get the cube root of x cubed, which is x. So h of f of x is equal to x. Great. Next up, I have f of h of x. So I start with 1 minus x cubed, but instead of the x cubed, I put the cube root of negative x plus 1. The cube root and the cube cancel each other out, so I get 1 minus negative x plus 1. This negative sign again distributes in, so I get 1 plus x minus 1. The 1 minus 1 cancel, so f of h of x is equal to just x. So are these inverses? Yes, they are, because the two compositions reduce to x. Next up here, number 7, are two familiar f and g functions. So we want to find f of g of x and g of f of x. And so I can try and fit it down here. So f of g of x, start with my f function, 3 over negative x, so that's negative 3 over x plus 2 plus 3 minus 2. So this one will definitely confuse some people because there's a lot There's a fraction, there's a negative. Just, keep it simple, go one step at a time, and I think you're going to see how this all plays out. So again, all I did was I replaced the x and plugged in this g of x function, 3 over x plus 2. Now when I distribute that negative in, I get negative 3 over x minus 2 plus 3. This is all minus 2. So over here, this would be 3 over negative 3x plus 1 minus 2. And so, I think I can already see what's going to happen here, but what would be the easiest way to combine this? A lot of people don't like the fraction in the fraction. So actually, I'm going to combine this denominator into one fraction. And that's going to be done using a common denominator. So this is negative 3x plus 1, which is plus x over x, minus 2. And so when I have this, it's going to be 3 over x minus 3 over x minus 2. Now this looks ugly, this looks scary, but actually this is actually very nice and very helpful. So when I divide, remember a fraction is nothing more than division, I can multiply by the reciprocal. So this is going to be 3 over 1 times the reciprocal of x minus 3 over x. It's going to be x over x minus 3 minus 2. So this reduces to 3x over x minus 3 minus 2. Is this going to reduce to x? Absolutely not. So this, because this does not reduce to x, then it doesn't matter if the other one does. These are definitely not inverses of each other. So that's it. Problem done. Now, just looking at this, perhaps, no, never mind. Again, even if this was f of g of x, even if g of f of x reduced to x, they still wouldn't be inverses of one another. All right, number 8 here. So we're going to look for h of f of x. So I have my h function, and I'm going to replace the x with the f of x. So 4 over x plus 3 plus 2. Let me just make sure I did all this. So 2 over x plus 2, and replace that with 4x plus 3. Good. So I can combine my 3 and my 2 to plus 5. And so we have a very similar setup as before for the previous problem. So we're going to have 2 over, if I make my common denominator, multiply this by x over x, I get 5x plus 4 over x, multiply by the reciprocals. So this is going to be 2x over 5x plus 4. Is that going to reduce to just a single x? No. So are these inverses? No, they are not. And so finally, number 9 here, g of f of x and f of g of x. G of f of x. I start with my g function, negative, this is a fifth root. Replace the x with negative 3 minus x to the fifth minus 1. Not really much can be done here. Yeah, this is really you can't take the fifth root here because of this 3, so it stays as that. So these are not inverses. These aren't great problems here. I should probably find some different problems. But this worked out nicely. Just stopping it right there. No more work needs to be done. So this looks like a good one here. So I'm going to start with f of g of x. going to start with my f function, x minus 2, and I'm going to replace my x minus 3 over 3 minus 2 with this function. So I have my g plugged into my x function. So I get x minus 3 over 3 minus 2. That's going to be 6 over 3. So this is going to equal x minus 6 minus 3 is minus 9 over 3. Yeah, again, this is this can't be reduced. So that's it. So no, that's not an inverse function. Right, so from these 5 problems, we had 4 no's and 1 yes. So look out for this equals x. But really, that's all you're doing. You're finding the 2 compositions of the functions. And to find the inverse, you switch the x and the y. Make sure you watch out for this notation. Don't leave this as f of x. Don't leave it as y. Make sure that you do put the correct notation there. But as long as you're comfortable with the start for this, then you should be pretty good. Feel pretty good about finding inverses and verifying inverses of functions.